Okay, hello. So this is a continuation of chapter 12 about IPv6 addressing. IP addressing. Last time is all what we covered. Uh, Started with, so far we've covered IPv6 issues, then IPv6 address representation, and then we have looked at IP address, IPv6 address types, and now we left with the two global unicast address and link local address static configuration, and then dynamic addressing for IPv6 global unicast address. Okay, um, for all this so far that I'm skipping, I refer you to the previous recording. So today we're going to cover, or we're going to go through global unicast address link local address static configuration, how to configure the two address. So like IPv4, so as you have to be in global configuration mode. As you can see, this is a global configuration mode, and then you call the int. So this you can abbreviate it as int, then g 0/0/0, and then you put the address. So here it's IP. You have to make sure that you put V. So it's IP. It's IPv6, then address, and then you follow the address on this. So with this one here, please, I want you to follow the previous syntax on how to set the IPv4, IPv6 address, and then IPv6 address, and then that is where you will be able to pick the IPv6 address to assign, and then after that, no shutdown. No shutdown is this, and then you exit. So right now, the global, if you remember very well, global IPv6 address, which is equivalent to public IPv4 address, it has to begin with a 2. It's either 2 or 3. And then the rest of this side, it doesn't matter as long as it's in the range up to F, or 0 up to F. But as long as they begin with this. And the slash for public, it's /3. It's /3. So if you want to assign IPv4 address, IPv6 address statically, so we expect this. Let me see if I will be able to get. Yeah, I think I'll. Okay, so let me share here, as you can see. Um, okay, so here my Ethernet cable, it is this. My Ethernet cable, it is this. So I will click on it, as you can see here. Yeah, so the addresses, they are here, and it is, I'm picking IPv4 address automatically. As you see, this IP address automatic DHCP, DHCP, and then the speed, it's 100 MBs. This, the IP address assigned, it's this, and DNS address, we have this, and then the alternate, there is this, the DNS suffix, this, the domain name, all this. All this. So I'm actually using the USB converter to convert, actually Type C to convert to Ethernet port, but this is not what I wanted. All I wanted I think it's advanced network settings. Okay, so uh, yeah, I think this is what we thought. I want to view more adapter. Okay, so this is what I wanted. Yeah, I wanted all this, but on your computer it may not be the same steps that for you to follow. So I was looking for this. Now we have, remember, we have what you call IPv4 and IPv6. So in case I want to set the IPv4 address statically, I'll just come and click on this, then properties, and then deal with this, the two here. So if I use this obtain IP address automatically, it means that it's going to contact the DHCP server for IP addressing information. But if I use this option here, use the following IP address, then it means that I know the address. I have to type them. For example, 192.168, maybe .10, .1, like that. Subnet mask, then the default gateway, maybe 192.168.1. Sorry, um, dot 10, maybe also dot 1, something like that. Meaning that the information, you know it, you have to type it there manually. That is what you call static. But the moment I use obtain IP address automatically, it means that the IP addresses are going to be assigned to these machines uh, by DHCP service, and then you click OK. So here I'm interested in IPv6. It's here, Internet Protocol version 6. So I'll click on it. Still, I go to properties. So the options, we have to still obtain an IPv6 address automatically, meaning that for you to use that service, you must, or there must be DHCP version 6 service enabled somewhere on the network to serve this client, DHCP version 6 client. So if I use the following, you see this? Now with this one here, it is almost the same as, let me have it here, and then try to bring this. Um, so here we are. So if I bring, um, looking for, oh, each one. But here, as you can see, it is almost, it is the same, not almost, it is the same. So here, this is where we type the IPv6 address, then the prefix length. You can type something like this, 2, let me put maybe 2, 0, 01, and then this, ACAD, DB, DBH, then 1, double, I can use double colon, and then 1. Now after this, then I'll put the prefix here. As you can see, it has come automatically, this, indicating that the prefix, it has 4 extents, 1, 2, 3, then 4. So all the bits there, they should be 64, and they should remain uniform on all these uh, the available IPv6 address. And then you can put the, still, I can give this 10 and then copy this and then call it maybe the default gateway like this, and then you click OK. You click OK. So automatically you actually be able to see the address. But I don't want to maintain this. I'll just remove by clicking obtain an IPv6 address automatically. So that is what I wanted to show you there. Then we have what we call link static configuration, link local unicast address. Link local unicast address, these are addresses that are used on point to point or on the same link, on the same link. So now we can have those two, we can have global unicast address and then link local address. Two addresses under a single interface. And how are we going to have those two? Now, when it comes to link local, remember its range, it's here. It's if any IP address that begins with this, then automatically that one, and the prefix length, it is 10/10. So this will be the link local address. And for you to actually have the second on top of the global unicast address, then you have to make sure that you add this statement, link local, link local address, link local address. So dynamic addressing, so there is a chapter about dynamic addressing for IPv6 addressing. So here I will just be a bit fast. So I will just pick another touch, and then here all I want is just to test the two with IPv6. Okay, so if I'm to assign the two addresses that we've talked about, I'll access the global configuration, and then code interface. I have G0, there was G0. Oh, I used 0, instead of 0, 0. And then say IPv6 address, and then 201, and then I can say DB8, ACAD, 1, and then abbreviate. So if I abbreviate, then I'll put the prefix length, which is 64. You see that it has accepted. And then I can actually go ahead and say IPv6 still, then address, then put FE, then HE, then abbreviate that way, and then put a 1. So if I press enter here, I will have replaced this, the previous one, this. So to keep this global unicast address alongside this link local address, then this I have to describe it by putting link local like that. Then you press enter, no, shut down. So if I want to verify, I'll use the command show IPv6 interface, then brief. Press enter. So this is what I'm from configuring this. That link local address, it is this one, and then the global unicast address, it is that. Okay, so how was it? We can proceed dynamic addressing for this. We just summarize this. There is a entire topic that is in semester 2 about IPv, the DHCP version 6. DHCP version 6, and whereby DHCP version 6 is under dynamic addressing for IPv6 global unicast address. So devices obtain global unicast address dynamic address through what you call ICMP, and ICMP it stands for Internet Control Message Protocol version 6. So we have what you call router solicitation messages that are sent by host devices to discover the router. Then we have what we call router advertisement, messages that are sent by routers to inform hosts on how to obtain the IPv6 global unicast address and provide useful network information. So in that network information or useful network information, it includes what you call network prefix, then prefix lengths. Yeah? The network portion and then the lengths of that network portion. For example, if there are 4 extents here, then the prefix length here it will be 64. Then the default gateway DNS address and then domain name. So the router advertisement can provide 3 methods of configuring an IPv6 global unicast address. We have what we call SLAC, which stands for Stateless Auto Address Configuration. And then we have SLAC with stateless DHCP. DHCP stands for Dynamic Host Configuration Protocol. And then we have what we call stateful DHCP. So in SLAC, the router, it uses router advertisements to tell or to instruct the end device on how to obtain the IP address by providing partial information, network information to the client, and then the other information to be generated randomly by the end device. When it comes to Slack, still it gives out partial, that some information is within the router advertisement, and then the other information it's from the DHCP server. Some information from the router and then the other information from the DHCP server. Then when it comes to stateful DHCP, there is no Slack, stateless address auto configuration. It's not there. They are not supported. That all information it has all the required information by client, it has to pick it from the DHCP server. So we talked about prefix and then the prefix length. So here method 1 with Slack. Slack allows devices to configure global unicast address without services of DHCP version 6. So the device obtains necessary information to configure global unicast address from ICMP version 6 router advertisement message of the local router. So the prefix is provided by the router advertisement, which is this, and then the device either extended unique identifier or randomly generation method or generation method to create interface ID. That now the router will provide this, and then the interface ID here, it's going to be either randomly generated or from extended unique identifier. The extended unique identifier, this one here, it is generated from the MAC address, from the MAC address. But when it comes to randomly generated, it depends on the operating system. So it's the operating system that generates that address. So method 2, where we have Slack and then stateless, that's information it's going to be generated from the router, and then the other information generated from the stateless DHCP version 6 server. So RA message suggests the device to use Slack to create its own IPv6 global unicast address. Then the router link local address, which is the router advertisement sets IPv6 address as the gateway. So a stateless DHCP server to obtain other information such as DNS server address and domain name. So for this other information, server address and then the domain name, it can be picked, or it has the client has to contact the stateless DHCP server for that information. And then this other information, the interface ID or global unicast address, then default gateway, all that information can be picked from the router through the router advertisement. Then method 3, we have stateful. With stateful, router stateful, this is similar to DHCP for version 6, version 4. A device can automatically receive global unicast address, prefix lengths, and then address of DNS server from stateful DHCP server. So the router advertisement message, it suggests a device to use the following: router link at link local address, which is the router advertisement source IP address for the default gateway, and then stateful DHCP server to obtain global unicast address, DNS server address, domain name, and other necessary information. So all that information, it will be picked from stateful. Supposed to be stateful, because this is a mistake. Stateful, not a stateless. It has to be stateful. So we have extended unique identifier process and then randomly generated. When the router advertisement message is either Slack or Slack with stateless DHCP version 6, the client must generate its own. Where we have Slack, it's a must. The address, it has to state, it has to generate its own interface ID. So the interface ID can be created using extended unique identifier process or randomly generated 64-bit number. So the router will provide the prefix, then the interface ID, it has to be created by the client device through extended unique identifier 64, meaning that this is the length of the length of interface ID, or randomly 64 bits, that they have to be 64 bits that are generated randomly. The IEEE defines extended unique identifier, or so the extended unique identifier, it can be called modified extended unique identifier process, which performs the following: that 64-bit value of FFFE in hexadecimal is inserted into the middle of 48 Ethernet MAC address. So here it's a combination of MAC address together with this that 16-bit value, the 16-bit value in hexadecimal, which is this. So it's a combination. So the MAC address, it's the 48-bit, then plus this, the standard, the mandatory F, F again, then E. So these are 16. If you add 16 to this, you get your 64. To generate or to form what you call extended unique identifier. So example is here. So we have this one here as FFE. So it's going to be this. Then in between 1, 2, 3, 1, 2, 3. So in between here, that is where the FFE is inserted. And then you count the 7th bit of the client MAC address is reversed from binary 0 then to 1. So if it is a 0, you change it to 1. If it's a 1, you leave it to 1. We leave it to 1. So when you look at this, we have F, but in here we have E. So it will be this. We can first convert this FC. This is 1, 1, 1, 1. Then C, it is 12C. So it is H, then 4, then 0. So when you count this, these are 4, 5, 6, 7. So it's this is the 7th bit and it's a 0. So it's going to be converted to a 1. So if you convert it to a 1, then automatically like this, it gives us 14, and 14 it is E, and now automatically it will be F then E, what we have here. But in between, we have FF, then E, which is this. And once you fix this, as you can see, the format, it's two hexadecimal values. It's a pair of two hexadecimal values. Decimal value. So it's this, even this one here, it has to be paired. It's F, then F, E, like this. So this it is, and in between, that's the reason why we have this. I hope that is clear. If it's not clear, then you will let me know. Okay, so here, randomly generated interface ID, we have it here, because the other one, it was extended unique identifier, now we have randomly generated. So randomly generated, when you look at this, we have every time you enable IPv6, then link local address, it is automatically also enabled. So with this, link local address, we have this and then this. So it's this one here that is added on the prefix. So when you look at this, we're counting 1, 2, 3, then 4. But whatever that we have here, it is the same as what we have on link local. So whatever that is on link local, it's what is picked and then added on the prefix to form what we call randomly generated interface ID. Dynamic addressing for IPv6 link local address. All IPv6 interface ID have must have link. It's a must that every time you enable IPv6 interfaces, then link local addresses are automatically generated. Like IPv6 global unicast address, link local address can be configured dynamically. The figure shows link local is dynamically created using this and then the prefix 10, and the interface ID using extended unique identifier process or randomly generated 64-bit number. So when you look at this, this is what is supposed to be constant. Constant. And then what we have in between here, it's the compression. That's the reason why there is nothing. Then the last, the interface ID, it can either be extended unique identifier or randomly generated ID. That is what we saw here, as you can see, that this is randomly generated, or it can be extended unique identifier MAC address inserted with the triple F and E. So here, dynamic link local address on Windows, when you look at this, wherever you see this, the triple F in between, you know that this is the MAC address. And since this is the MAC address, it is generated from the MAC. It's link local address, but whatever the interface ID that is added there, it's from the MAC address. And then automatically it's the one that is placed in the position of interface ID. Then we have randomly generated ID, which is what I explained previously. As you can see, it's this. But this you can actually go ahead and duplicate, you can go ahead and sign it manually by putting exactly what you can easily remember, replacing this, and you come up with something like this. Now this one here, wherever it is assigned, it's on the router, not on the PC. But on the router, it is manually assigned. That's the reason why we have a 1, and yet it is either that the interface ID, it can either be generated from randomly generated It can be randomly generated or from extended unique identifier. So dynamic link local on Cisco router, as you can see. So we have this show interface gigabit Ethernet that we have. When you look at this is the MAC address that we have, the MAC address of this interface. But when it comes to show IPv6 interface brief, we're saying that the link local address, this is what it has. The moment you see this, you know that that is the MAC address. Whichever interface ID that is used, it's generated from the MAC address. But now when you compare the two, this and then this, they are not the same. Here we are seeing 70, 79, but here it's 72, 79. Where is the two coming from? So we have this 70, then 79. We're going to convert these two. So a 7, we have 8. 8, it's not there. We have 4, then 2, and then 1. So this is 4 plus 2, 6, then plus 1, which is 7. Then when it comes to a 0 there are 4 zeros. So we said that the 7th bit, if it's a 0, you convert it to, you reverse it to 1. So this is 4, 5, 6, then 7. So we're going to convert this. Now if you convert this to a 1, then automatically this is a 2. So this is a 7, becomes 7, and then a 2. That is where the 2 is coming from. Then 7, 9. Because that is the syntax, it's the rule, the principle that once the triple F is inserted into the MAC address, then the 7th bit, if it's a 0, it's converted or reversed to a 1. Verifying IPv6 address configurations, I showed you this, guys. Showed you this by running, because actually we can try on this other packet trace of ours that I will pick another switch. Let me pick another switch, add it here, pick a cable, and then pick on this, and then to this one here. So if I enable and then go to configure channel interface, then G0/1, and then say IP address, supposed to be V6, then address, I'll use 2001, and then DB H ACE, then put a 2 on a 1/64 then no shutdown. So what I want here is to see how the link local address is going to be generated. So I'll go back to privilege and then run the command show IPv or IPv6 interface brief. So I'm interested in this interface. So when you look at this, I have my F. It is here. F. Show, I can even show interface, then G01. What do I have here? Okay, I'm interested in this. This is its MAC address. just 0 this. Now when you look at this one here, F, then this. Oh, okay. Anyway, let's go with this. That when you look at this, that now the link local address, it is generated from the MAC address. Why? Because of this triple F in between. Period. Okay, this is packet tracer configure IPv6 addressing in your accounts. Yeah, you'll be able to go through this. Uh, uh, then subnetting, subnetting, subnetting or subnet an IPv6 address. It is very easy when it comes to IPv6. So IPv6, it's actually, we're subnetting, or if you're to subnet most of the time, you can subnet what you call global unicast address. So it has the global routing prefix, then subnet ID, and then interface ID. So if you have, you can decide, I will have maybe 201, then DBH, ACAD, like this. This is a 40, this is 16, 16, 16, total into 48. Then we have this, we can call this maybe a 0, and then even all these other ones, we give them zeros. Like this, like this, like this, and then even this. So if I want another group of IPv6 without doing lots of changes here, I will just change this to a 1. I will just change that to a 1. So I will change this to a 1. So this will be the second a 1. It will be the second subnet. I can change that to a 2. The subnet ID changed to 3. So this will be the same, but all these other ones, they will remain the same. But I will have got the other IPv6 address group. So that is how you subnet in IPv6. So it's not complicated. Maintain this, the global routing prefix, and then you and then you keep changing the subnet ID to different figures, to different values. From 0, as you can see, we started with the 0, then 1, 2, 3, 4. So that is it. That is how you subnet. Then lastly, last but not so here we have our address. Given this, we are given this address here, /48, routing prefix with 16-bit subnet ID. So you just maintain this, and then the next 16 bits, it's what you keep on changing, as you can see here, that we have this, it's uniform slouch, but when it comes to this, you keep changing it, keep changing it. So the assignment on this, I want you to generate any 48 bits like this. You can use an example, maybe like something like 20, maybe 2, then A, A, B, D, maybe F, A, C, like this, on this. And then you start from 0, 1, 2. But the other side, of course, this side, it's the interface ID. And if you leave it this way, but at least try out something. So all I want is you not exactly this, come up with something that is different, but you make sure that you come up with different subnets, as many subnets as you can. So here we have IPv6 subnet allocation. This is a topology. That I'll actually do another on this, not as of now. Then how to assign? Yes, I will have this as practical, but it should not stop you from going through it. And then even here, how to assign an IP address, I already sampled you how to assign IPv6 address. So that is the end of chapter 12 about IPv6. Thank you.